Hi, so our lesson today is going to be on simplifying trig expressions. So we're going to start maybe with some problems that kind of look a little confusing, a little complicated, and we're going to try to simplify them down by substituting in things that we know are equivalent and maybe things that'll cancel out or otherwise just kind of simplify and get a little neater. So what we're going to use for those are the fundamental identities that you learned about in the last section, last choice board, and what you want to think about with these fundamental identities is these are things that are always true for any angle at all. It doesn't matter if the angle is negative, positive, acute, obtuse, right. These are just always true. So for example, your reciprocal identities, the sine of any angle theta is always equal to 1 over the cosecant of that same angle theta. So for any angle, these thetas could both be 30 degrees, or they could both be 119 degrees. They could be negative pi over 17 if you like to work in radians. So it doesn't matter what the theta is, always works. So the reciprocals, sine and cosecant go together, cosine and secant go together, and then tan and cotan go together. So they're kind of your upside down versions of one another. Quotient identities, those are for tan and cotan. So remember, tan is kind of like the slope, right? It's kind of like a y over x sort of thing. Well, sine's kind of like the y and cosine's kind of like the x. So tan ends up equaling sine over cosine. And that's always true for any angle. If you take its sine, divide it by its cosine, that will equal its tangent. And the upside down version is true for cotan. Your Pythagoreans, these go back to kind of x squared plus y squared equaling 1. That's the formula for the unit circle. And we know that cosine's kind of like the x and sine's kind of like the y. So this ends up being true. Sine squared plus cosine squared equals 1. To get to these other two, if you're ever trying to remember them, you can divide all three terms by cosine squared on the first one, and it will take you to this one, tan squared plus 1 equals secant squared. If you divide all three terms on the top one by sine squared, it will take you down here to this one, which is also always true. 1 plus cotangent squared equals cosecant squared. And when you see these exponents, keep in mind, like sine squared theta, what that's talking about is whatever the sine of theta is equal to, if you square that, that's sine squared theta. So to be clear, they're putting the exponent right on the sine and before the angle theta. I guess to make it obvious that you're not talking about squaring the angle, you're talking about squaring the sine of that angle. All right, so if you want to simplify stuff, here are some strategies. If you see squared stuff, like we did on the last page, or if you see a 1, think about using a Pythagorean identity. It might be helpful. If you see secants and cosecants, definitely think reciprocals. Also cotangent, that can be useful sometimes. If you see cotangents and tangents, you can think about the quotients as well. And if all else fails, that means you're just kind of stuck. You don't know what you're supposed to be doing. It's not obvious to you how to simplify it. Try turning everything into sines and cosines and see if that doesn't make it easier. A couple example problems here. Sine squared x plus tan squared x plus cosine squared x. So you've got this expression, it's got three terms, you'd like it to be simpler. So you look at it and the thing you notice is these exponents. Okay, that makes you think, feels a little bit like a Pythagorean maybe. And since there's a sine squared and a cosine squared and they're added together, we know that equals 1. We can substitute in a 1 in place of sine squared plus cosine squared. So what that gives us is 1 for the sine squared and the cosine squared, and then still left with plus tangent squared x. And you have to excuse my handwriting here because I'm just writing with my finger on my touchscreen. So 1 plus tangent squared x is equivalent to this original expression, but somewhat simpler. Now, are we done? I'd kind of prefer to get it even simpler. I'd like to get down to just one term if possible. So I see that this still looks kind of Pythagorean-ish. So 1 plus tan squared, coming back to the Pythagoreans, sure enough, that equals secant squared. So once you're down to just one term, that's the best you're going to be able to do with it. So secant squared, and you're noticing I'm using x's on this one. Doesn't matter if it's an x or a theta. Those are kind of interchangeable. So as long as you're consistent within the problem, you can use x's, thetas. You might even occasionally see other Greek letters. So secant squared x, that's about as simple as you're going to get this one. It's just a single positive monomial. All right, one more example. We're going to simplify secant theta, sine theta, cotangent theta. So the way this one's going to work, it's not obvious exactly what I'm supposed to do. The whole thing looks a little confusing. They're all multiplied together, but I wish it wasn't three different pieces. I wish it was kind of just one thing maybe, or at least two would be better than three. So how am I going to simplify this? I guess for secant, the only thing I really know about secant is that it's 1 over cosine. So I think I'll try that. As far as the sine, I'm not really inclined to mess with that one right at the moment because, well, sine is the one I'm the most familiar with. It's the one I'm the most comfortable with, and I'm just going to kind of prefer to leave that one. So if I'm multiplying it, since I had a fraction on the first one, I'm going to go ahead and call this one sine theta over 1, just to kind of be consistent and make it all a big fraction. And then cotan theta is my last one. Since I'm in terms of sines and cosines on these first couple, I'd like to just go ahead and be all sines and cosines. So even if you're tempted to call this last one 1 over tangent, I think it's probably more useful on this one to call it cosine over sine. So cosine theta over sine theta. Now you've got some canceling you can do. These terms are all multiplied, right? No plus signs or minus signs anywhere. So what you can do is you can cancel some things. I've got a cosine theta on the top, and that can cancel with the cosine theta on the bottom here. I've got a sine theta on top. It can cancel with the sine theta on the bottom here. Look at this. Everything has canceled. So I'm just left with 1 over 1, which is, of course, equal to 1. So it turns out this complicated looking thing that I started with, secant theta, sine theta, cotangent theta, really just equal to 1. And a lot of these problems will just kind of fall into place if you just play around with them for a bit. So that's your quick lesson on simplifying. I hope it was clear. We're going to give you some other resources that you can use to practice and get ready to get all your work done. Thanks.